In almost any complex system, a massive percentage of the outcomes are driven by a very small fraction of the inputs. If you can identify that concentrated core, you can solve the majority of your problems without wasting time on the noise. This mathematical observation is named after the Italian economist Vilfredo Pareto. In the late 1800s, he noticed that roughly 80% of the land in Italy was owned by just 20% of the population. Over time, industries realized this distribution applied to their operations too. In pharmaceutical quality management, this plays out on the manufacturing floor. You will typically find that 80% of your defects, deviations, or customer complaints originate from just 20% of your process steps. We call these critical few steps the vital few. By isolating them, a quality team can direct their limited corrective and preventative action resources exactly where they will generate the highest return on effort. To actually find those vital few, you have to organize your raw data. That means defining the problem you're tracking, collecting the frequency of those occurrences, grouping them into distinct categories, and then ranking them. Let's look at a concrete example. Suppose a facility records exactly 100 deviations in their tablet compression process over a given quarter. This chart shows exactly how deviations break down. Along the x-axis, raw data is grouped into specific causes. Notice their arrangement. The blue bars represent volume, ordered highest to lowest. Granulation moisture leads with 40, machine issues with 25, and operator error 15. Forcing the data into this strictly descending order is the crucial first step. It visually separates the most frequent issues on the left from the long tail of minor, infrequent problems on the right. To read this properly, understand the two different y-axes. The left axis measures absolute frequency, exactly how many times each problem occurred, aligning with the blue bars. The far right axis measures cumulative percentage, capping at 100%, tracking the running total. Look at the first three categories. Adding their occurrences, 40, 25, and 15, out of 100 total deviations, what percentage is that? Exactly 80%. The red cumulative line charts this visually, climbing until it hits that 80% mark. This mathematically confirms that granulation moisture, machine issues, and operator error are your vital few. Rather than trying to fix everything at once, the quality team now knows exactly where to direct their efforts. Updating the drying processes or calibrating those specific machines will resolve the vast majority of the site's deviations. By mastering this dual-axis chart, you move away from guessing and prove with data exactly which interventions will yield the highest results. Pareto analysis provides immediate visual clarity, helping cross-functional teams reach consensus and allocate their resources efficiently. However, there is a serious pitfall. Relying strictly on frequency data can cause you to overlook low-volume but catastrophic impact events. The 80-20 rule is a guide for managing volume, not a substitute for risk assessment. A single instance of a fatal contamination risk must always take priority over a large volume of harmless documentation errors. Severity overrides frequency. When used correctly and paired with sound risk management, Pareto analysis is an incredibly effective tool. By isolating those vital few causes, teams achieve maximum improvement with minimal wasted effort. If you found this breakdown helpful, make sure to subscribe to the channel for more step-by-step training on pharmaceutical root cause analysis and quality management.